Welcome to Pankaj's Echelon Tutorials. In this today's session, I have chosen a topic called arithmetic progression, and this is for the IGCSE additional mathematics. Okay, so in this particular topic, now this topic I will be dividing into so many parts, and in this particular session, we are dealing with part one. So I'm starting with just part one. And in this, I'm just going to clear the basic concepts of arithmetic progression. Okay. Now, in your lower classes, your right from your seventh, eighth grade, ninth grade, okay, you were studying something called sequences, right? So you know what are sequences, right? But then once you know what is a sequence, okay, then you can classify those sequences into too many categories. So there's something called an AP sequence, or you can call it as arithmetic progression. There's something called GP sequence, or you can call it as geometric progression. There's something called okay, uh, HP sequence, which is also known as harmonic progression. Okay, and there are many more, right? So these are the different types of sequences. As far as additional mathematics is concerned, you have to deal with only the AP and the GP, these two type of sequences. Okay. So with that as the focus, I'm going to start with what is an arithmetic progression, but I will give you an idea of what is a geometric progression as well, so that you can be in the position to differentiate the two. Okay. So let us get started with these two examples. Number one, suppose I tell you that this is a sequence 2, 5, 8, 11, 14. Okay, fine. Now this is a sequence, right? Second, let me give you a sequence like -2, okay, 0, okay, 2, 4, 6, and it goes on. So here I'm giving you two sequences, and let me give you one more. Third one is, suppose you have a 3, you have a 6, 9, 12. It goes on, right? Now let us try to analyze these three sequences. So going by the sequence number one, you can see that, first of all, you can see that it has only 1, 2, 3, 4, and 5 terms. Okay. So this sequence 2, 5, 8, 11, and 14 has 5 terms. And that is why it is known as a finite sequence, right? Okay. Now this 2, term number 2, this term 2 is on the first position. This is second position, third, fourth, and fifth. So this is known as the position number. In general, we write this as n, and this is known as the term. Okay. So on position number 1, you have a term which is 2. On position number 2, you have a term which is 5. On position number 3, you have a term which is 8. On position number 4, you have a term which is 11. And on position number 5, you have a term which is 14. This can be denoted like T1 is equal to 2, T2 is equal to 5, T3 is equal to 8, T4 is equal to 11, and T5 is equal to 14. Fine. So these are the terms. The first term, second term, third term, fourth term, and fifth term. Okay. And in general, it can be written as Tn. Okay. So many books, they write this as Tn. In some book, they denote by An. In some book, they denote by Un. So different notations is used for these sequences. Okay. So you can say that Tn or An is a sequence uh, A1, A2, A3, A4, and A5. This is in general, either T1 or A1. Let us choose A1. Okay. So this is a sequence. Okay, in general. In particular, this An is equal to, if we choose this to be the sequence, it is 2, 5, 8, 11, and 14. Okay. So A1 is the first term, A2 is the second term, A5 is the fifth term of this particular sequence. Now, let me see what I can uh, see something peculiar about this sequence. If I do A2 minus A1, okay, A2 minus A1, I get 5 minus 2, which is equal to 3. Fine. Let me do A3 minus A2, and this will be 8 minus 5, which again gives me the answer 3. So can you see I'm getting a constant difference when I do A2 minus A1 and when I do A3 minus A2. Okay. So when you do this and you get a common difference, or if you get a constant difference like 3 in this case, then this 3 is called as the common difference, CD. Okay. And this common difference is denoted by D. So for this sequence, the D is 3. And whenever you have a common difference in any sequence, that sequence is called as an arithmetic progression. So this sequence is also an arithmetic progression, or this sequence is of the first type, arithmetic progression. So in other words, if a sequence is given to you and if you want to identify whether it is an AP or not, then what you have to do is you just do A2 minus A1 and do A3 minus A2. Okay. And if the answer to both this, you are getting a constant value, like there, in this case, you are getting 3. Then you can say that it is an AP. And if it is an AP, that D will be equal to 3, which is the common difference of this arithmetic progression. And the first term of this sequence will be A1, which in this case is 2. Okay. So this is an AP. This is an AP which has A1, that is the first term, as 2, and it has a common difference as 3. So any arithmetic progression can be completely described if you know the first term and the common difference of that sequence. Okay, so any arithmetic progression should have these two things, that is the first term and the common difference. Got it? Now let us try to analyze this example number 2. Now in this example number 2, you can see this is the sequence, but this sequence is, it goes on. So this is not a finite sequence, it is infinite. It is infinite. Now let us check whether it is a AP or whether it is not an AP. So for that, what I'll do this A2 minus A1, that is 0 minus minus 2. So I'll get 2. Okay, 0 minus minus 2 is 2. Let me do this 2 minus 0. This is also 2. So I am getting this constant value 2. So I can say this is an AP. Okay. And it has the first term A1 as minus 2. And the common difference D is this 2. Okay. Fine. So sequence number 1 and sequence number 2 both are AP. Okay, arithmetic progression with first term and the common difference that has been identified. Only difference in these two sequences, the first one is a finite sequence. It consists of only 5 terms, 1, 2, 3, 4, and 5. And the second one is an infinite sequence, okay, because this goes on. Now let us try to check what this sequence 3 is. Now sequence 3 is 3, 6, 9, 12, and it goes on. So first of all, it is also infinite. It is infinite. Now let us check whether it is an AP or not. So I'll do this 6 minus 3. 6 minus 3, I'm getting 3. Then let me do 9 minus 6. 9 minus 6 is also 3. Okay. And 12 minus 9. This is also 3. So this third one is also an AP. Okay. And you can see that the common difference is 3 over here. And the first term is also 3 over here. So here also, this is an AP with a common difference of 3 and first term being 3. So these are 3 examples of arithmetic progression that I have given you. Okay. Next, you have to understand what is the meaning of a general term. Okay. Now, what is the meaning of a general term or the nth term? There's something called nth term or general term. Okay. Now, let us go back to the sequence number 1. Okay. It was 2, 5, 8, 11, and 14, right? And A1 was 2 and B was 3, isn't it? Now, this AN, this sequence can be written as, okay, the general form, or you can say the nth term. So this is the nth term or the general term. The nth term of the general term of this particular sequence can be written as first term plus n minus 1 times d. This is the general term ka formula. This is the formula for the general term or the nth term. Okay, this is the general formula. For this particular sequence, an, okay, here a1 is 2, so I'll put 2 over here, plus n minus 3, and d is 3, so I'll put 3 over here. Now if I work out this, this will be 2 plus 3n minus 3, which will give me 3n minus 1. So can you see I'm getting an is equal to 3n minus 1. This particular formula is known as the general term, or it is also known as the nth term of which sequence? Of this sequence. Is that clear? Now you may wonder what way this general term is going to help you. Okay, fine. Now this general term will help you in finding the other terms of this sequence. Okay, so this is a sequence, so it should go on, right? Only the first 5 terms are given. But suppose I want to find out the 7th term. Okay, suppose I want to find out the 10th term. And if I want to find out the 21st term. So what I will do? Okay, so for finding the 7th term, I'll in this formula, n I will take as 7. So this will be a7. And in this formula, for n, I'll put the value 7 minus 1. So this gives me 7 3s are 21. 21 minus 1 is 20. So my 7th term is going to be 20. Same way my 10th term will be what? My 10th term will be a10, which is equal to, in this formula, 3 times 10 minus 1. This is nothing but 10 to is 30. 30 minus 1 is 29. So my 10th term, that is a10, is going to be 29. 21st term. 21st term is nothing but a21. This will be again 3 times 21 minus 1. Now 3 times 21 is 63 minus 1. So this is going to be 62. 62. Same way, if I go on and if I want to find out some nth term, then my nth term will be this. It will be 3n minus 1. So I hope now you must be understanding that how important this general term is. Once you know the general term, you can develop the entire sequence. Okay, from term number 1 to any nth term, you can form a sequence. Okay, so there are two things in this: finding the general term of a sequence, how to find out the general term of a arithmetic sequence or arithmetic progression. I told you just now, this is the formula. Okay. One more thing, let me tell you. Once you know the sequence, another concept is, this is one concept of something called general term. Okay. Now the next concept is something called the sum of the n terms of any sequence. Now sum of the n terms is denoted by Sn. What is the meaning of this? Sn means what? The sum of the n terms. Suppose I want you to find out the sum of these three terms of this sequence, the first three terms of this sequence. So I will write this as S3 because I'm taking only the first three terms, n equal to 3. Right? So this three terms ka sum if I want to find out, then the formula will be what? So in general, the formula for Sn is for an arithmetic progression. Okay. Now all this I am telling you about arithmetic progression, not about geometric progression. Geometric progression will have the same things, the same terminology, the same terms, but then the formulas will be different. Okay. So Sn for the arithmetic progression is given by this formula, n divided by 2 bracket 2 times a1 plus n minus 1 times t. This is the formula for Sn. And there's one more formula for Sn. I'll give you for your reference. Okay. It is n upon 2 bracket a1 plus l. Now you may wonder what is this l. Okay. So this particular formula is used for sequences like this. That is the finite sequences. So in the finite sequence, you will be given the first term, like here it is 2, as well as the last term. In this case, it is 14. So when first term as well as the last term is known to you, and if you are asked to find out the value of Sn, that is the sum of the n terms, then this formula is very useful. Okay, because this will be taking into consideration the last term, which is L. So L is the last term. But if the sequence is infinite, you don't know what is the last term. So there you won't be able to use this formula. There you'll have to use this formula. Okay, so for Sn, you have two formulas. So this is concept number 2. Concept number 1, general formula. Concept number 2, the sum of the n terms of an arithmetic progression. It has two formulas, right? This and this. So with these two as the background, and let me tell you one more thing before I end up all the concepts of arithmetic progression. There's a third concept which is connecting this general term an of an arithmetic progression with the Sn. Okay, so an will be equal to Sn minus 1. Now this is also a very important and handy formula. Suppose you want to find out an, the general term of a sequence, and they have given you information only of Sn and Sn minus 1. Okay, only this information. Then you can just do Sn minus 1. Whatever answer you get, that will be the an of that particular sequence. Now when we do the numericals, in some of the numericals, we will be using this formula as well. So remember these three formulas for arithmetic progression. The general form or the general term is an is equal to a1 plus n minus 1 times d. This is the first formula you should remember. Second is the formula for the Sn. Now there are two formulas for Sn. So you can take this as a and b. So this is a and this is b. And the third formula is an is equal to Sn minus 1. This formula is also very, very helpful in certain cases where, you know, information is limited. You don't know anything about D, you don't know anything about the first term, but then also still you can find out an by making use of this Sn. Okay. So if Sn is known to you, that is the sum of n terms, then that minus sum of one term less than n, that is known as Sn minus 1. Okay. That difference will give you an. Is that clear? Fine. So with that as the background, I have made you understand the concepts, the basic concepts of this arithmetic progression. Now let us try to solve some of the numericals so that you will come to know how this arithmetic progression uh, problems are to be solved. Okay, so let us try this first numerical. Uh, the question says that find the number of terms. You have to find the number of terms in the arithmetic progression. Now the progression is given as minus 17, comma minus 14, comma minus 11, comma minus 8, and it goes on, and lastly it is given as 58. Okay, so this is the arithmetic progression given to you, and they have asked you to find out how many terms are there in this arithmetic progression. Okay, now the meaning of this is, I'll write this way: position number, in general we write it as n, and these are the terms. Okay, so on position number 1, the term that is given to me is minus 17. On position number 2, I have term minus 14. On position number 3, I have minus 11. On position number 4, I have minus 8. And then it goes on. And at some position, I don't know what position is this, that is the last position. Okay, the term is 58. So this is my nth position. Okay, is that clear? So you can say that in this arithmetic progression, your A1, that is the first term, is minus 17. Fine. What is D? D will be this second term minus the first term. Okay, so minus 14 minus minus 17, that is minus 14 plus 17, which happens to be 3. And this will also be 3. Minus 11 minus 14 will be minus 11 plus 14, which is also 3. So your D is 3. So for this arithmetic progression, the first term is minus 17 and the common difference D is 3. Fine. And you know the general term of this sequence is written as an is equal to first term plus n minus 1 times D. Going by that, your first term is minus 17. So I'll write for A1, I'll write minus 17 plus n minus 1. For D, I'm going to write 3. If I expand this, this will be minus 17 plus 3n minus 3. This will give me 3n minus 17 minus 3 is minus 20. So this is my general term, or you can say the nth term of this particular arithmetic progression. Fine. Now I know that the nth term is 58. Okay. So I can write 58 is equal to 3 into n minus 20. The question asked here is find the number of terms. Now the number of terms is nothing but your n. Okay, you have to find out how many terms are there. If you find out the value of this n, that will be the answer for this number of terms. Okay, so 58 is equal to 3n minus 20 is a linear equation in n, and if you solve this equation, definitely you will get the value of n. So let me solve this. This will be 58 plus 20 equal to 3n, which is nothing but 50, 60, 78. equal to 3n, and this will give me n equal to 78 times 3, which works out to uh, 26. Okay, 26 is the answer. So my n is equal to 26. Therefore, the number of terms in this sequence has to be 26. Is that clear? Fine. Okay. So that was question number 1. Now let me do one more question. Question number 2 is find the fifth term. Find the fifth term, okay, of an AP. Rather, it is given not find the fifth term. They have given you the fifth term. Okay, so let me change the question. It is not find the fifth term. It is the fifth term of AP is 4.4, and the ninth term of this AP is 7.6. Okay, now he is telling you to find the first term and the common difference. Now in this question, he has not given you the AP. He has not given you the AP term wise. Okay, he has just told you that the fifth term, that is A5, is 4.4, and your ninth term, that is A9, is 7.6. This is what he has given. And definitely it is an AP that is also given. And he has asked you to find out the first term and the common difference. So you have to find from this A1 is what and D is what. Okay, this is what you have to find out. So here again we are going to make use of the nth term formula. So you know that the nth term or the general term for any sequence an, any sequence means any arithmetic sequence, arithmetic progression, an is equal to a1 plus n minus 1 times d. Okay, now he is telling you that a5 is 4.4. So in this formula, if I take this n as 5, so it will be a5 equal to a1, you don't know, so keep it as it is. And because you have taken fifth term, so n will be 5. So this will be 5 minus 1, 4. And d is unknown to you. And this a5 is given to you as 4.4. So can I write this equal to 4.4? So I'm getting this equation. Okay. Same way, making use of this a9, the ninth term. Ninth term will be equal to a1 plus n minus 1 times d. Now you don't know what is this a1, you don't know what is d, but you know what is a9. The ninth term is 7.6. Can I write this 7.6? So I get another equation which is a1 plus, now here n is 9. Okay, so 9 minus 1 will be 8. 7.6. Okay, 7.6. 9. So this is the second equation that I am getting. Now you can see that these two equations, okay, are linear equations in two variables. So I can solve them simultaneously to get the value of a1 as well as d. So let me write the equation once again. A1 plus 4d equals 4.4. A1 plus 8d equals 7.6. Right? Fine. Now just to get rid of this decimal point, let me multiply both the equation by 10 throughout. So this will be 10a1 plus 40d equal to 44, and this will become 10a1 plus 80d equal to 79. Now if I want to solve these two equations simultaneously, I will do subtraction. So this minus this I will do. 10a minus 10a will be 0. 10a1 minus 10a1 will be 0. This is 40 minus 80d will be minus 40d. Got it? And 44 minus 79 will be minus 9 minus 4 is 5 and 7 minus 4 is 3. Okay. So my D will be equal to a minus 35 over a minus 40, which is equal to minus minus will cut. So it will be 7 5 7s are 35 and 5 8s are. So my D works out to 7 upon 8, which is nothing but 0.8. Okay. So this is what I'm getting D. Now I got this answer for this D. Okay. I got this D equal to 0.8. Now I want this A1. So in any one formula, okay, suppose I take this one. In this, I'm going to put the value of D. So I'll get A1 plus 4D. Now D is 0.8, so I'll put 0.8 equals 0.4, right? So A1 will be equal to now 8 times 4, 0.8 times 4 will be A1 plus, it will be 8 for the 32, the 3.2 equals 4.4, right? So my A1 will be equal to 4.4 minus 3.2, which is equal to 4 minus 2 is 2 and 4 minus 3 is 1. So this is my A1. So I'm getting the answer for A1 as 1.2. Okay. So this was my second question, in which I have used the concepts of this arithmetic progression, and I have found out the value of the first term as well as the common difference. Okay. So these type of numericals now you will keep on doing in the future lectures, in the further topics as I cover. Okay, in part 2, part 3, we'll be doing so many numericals based on this concepts of arithmetic progression. So that's all for today. I just wanted you to introduce this arithmetic progression to you people. And this is, mind you, this is from the additional mathematics uh, book only. And this is a very good concept, because there will be related concepts coming to you in the higher classes, that is geometric progression, harmonic progression, etc., etc. Okay. So that's all for today, and I hope you must have liked this session. Okay. In the next session, we'll be doing more and more numericals on arithmetic progression. That's all for today. See you.